The last part of 3.3 is something called curve analysis, and it is a big topic on the AP test. That's why I have AP topic here and all these little asterisks. And the idea is instead of giving you an original function and asking you about the derivative, curve analysis means they actually give you a derivative graph, a picture of the f prime, and ask you about the original. So kind of like a working backwards. We're going to do a lot more with this later in the chapter. Today's just kind of like the first level, the beginning of this. So we're going to look at three different pictures here. So what you're looking at on your screen is a graph of f prime. They have to tell you that in words, in labels, that it's a graph of f prime. The questions they could ask are all going to be about the original function. So I'm going to make a little list over here of what they could ask. They won't ask everything. They'll usually, Delta Math will pick like one of these things to ask about. So the first thing they could ask about is they could ask when the original function is increasing and when the original function is decreasing. And here's how we tell this. So if we're looking at a graph of the derivative, the sign of the derivative is what determines if the function is increasing or decreasing. So that's going to be where the graph is located. You want to think of everything in the top part of the graph, so everything above the x-axis, as where the derivative is positive. So I put these little plus signs to help me. So that tells me that right here at x equals 3, it crosses over to above the x-axis and it remains above the x-axis the rest of the time. So I would say that the original function is increasing from 3 to infinity. Sometimes on Delta Math, they'll do like a certain interval, so it won't go to infinity. Decreasing is going to be everything that is located below the x-axis because that's when the derivative is negative, meaning it has a decreasing original function. And so that's going to be everything prior to 3. So we're going to write it as negative infinity to 3. You could also write like x is less than 3 if you want to write it with inequality signs. So that's the first thing they could ask. This one's a pretty basic one because it just has that one place where it switches. Now, if it actually equals 0, that's a critical value. And so they could ask you what type of critical value is it? So they could ask you about extrema. Since the function, we now know that goes from decreasing to increasing, so decreasing to increasing, we know that that value must be a minimum. So we can say that there is a minimum at x equals 3. There are actually no maximums of the function because there's never a time where the function switched from increasing to decreasing. And the last thing I do want to mention this, there's no way to know the y value. I always seem to be pushing for like full coordinates. In order to get full coordinates, I have to give you the original function because that's where you plug the x value into. I don't have that. So the only thing I can say is that I know there's a minimum when x is 3. I have no idea what the y value is that's associated with it. So let me show you another one. So again, this is a graph of a derivative. I put the little pluses on top and the minus on the bottom as a way to help you. That's something you, if you want to get in that habit, you can do. So we're going to talk increasing, decreasing, and extrema. So again, increasing function means the derivative is positive. So that's everywhere the derivative graph is above the x-axis. It happens, we can kind of highlight it here, and then it happens again here. So those intervals would go from negative infinity until it gets to negative 2, and then from 2 to 4. They do not care if you use parentheses or brackets around the numbers. I'm just kind of stuck in my ways with parentheses. Then decreasing would be everything that's underneath because that's where the derivative is negative. So kind of color code this one. So in this case, I am decreasing from negative 2 to positive 2, and then again from 4 to infinity. These two answers should encompass the entire, in this case, the entire number line. If it's a certain interval, it should encompass the entire interval. So now for extrema. So I know I have extrema happening at negative 2, at positive 2, and at 4, because these are all the places that the derivative does change signs. So we just have to figure out what type of extrema is it. So at negative 2, it goes from above the axis to below. So that means it goes from increasing to decreasing. So that must be a maximum. At positive 2, it goes from below to above. So that means it goes from decreasing to increasing. So that must be a minimum. And at 4, it goes from above to below again. So positive derivative to negative derivative, that's a maximum. I have no way of knowing what the y values are, but I can always find where my x values are and what type of extrema they are. Let me show you one more. This one's a really simple one, just kind of show you some of the different difficulties here. So this one, my list here. So what you'll notice about this one is this graph is always above the x-axis. So that tells me that it's always positive. We would call this strictly monotonic because it's always positive derivative. So that means it is always increasing, which means it is never decreasing, which means it has no extrema. We would call this a critical value because it does have a place where the derivative equals 0. It touches that x-axis, but it does not switch signs. And sometimes they'll ask that. They will ask, is there a place where you have a critical value, but you don't have an extrema? So on Delta Math, what they'll do, just to give you an idea, so you'll be doing this one, they're not going to ask you everything. They're going to ask just certain things. So for example, here's a really messy derivative function. They're going to tell you it's a derivative. It says in the problem, it says next to the picture. And they only want you to worry about -9 to 9, so you won't have to worry about you writing infinite values. And it wants to know any place that it has a minimum. So you are looking at all your critical values. So you're looking at all your critical values. And you're trying to figure out, now this one's a critical value, but it does not end up being an extrema because it does not switch signs. It doesn't go from below to above. So I've got 5 options. I have to figure out which of those are minimums. So a minimum is going to go from decreasing to increasing. So it has to have a negative derivative to a positive derivative. So the derivative is negative, and then the derivative is positive. And that happens at -4. It happens at -2. And that's actually it. So those are the types of questions they're going to ask on Delta Math. They're not going to ask you to do everything that I did, but they're going to pick one. So you might have a problem that says, when is it increasing? So you're looking for when is the derivative positive. You could have a question that says, when is it decreasing? So that's what you're going to be asked to do on Delta Math with these analyzing questions.